Now that we understand how data is stored in Cosmos DB, we need to talk about how it handles operations at a global scale. As we have one resource that is writing data on one side of the world, how do we manage how that data is presented to users on the other side of the world? You want to have your data closest to the user as possible to provide the best user experience. The closer the data is, the lower the latency to access that data will be. Cosmos DB allows this to happen by providing a multi-master experience. This means that by leveraging Cosmos DB, your application is going to be able to read and write data using a local Cosmos DB instance. In this example, user A will talk to the traffic manager, which will then route traffic to the closest region the application is deployed to. In this example, it would be in the same region, region A. Region A has a web app and a Cosmos DB instance. The user will read and write data to that local Cosmos DB instance. User B and C will also talk to their appropriate regions when interacting with the application. The consistency level settings within Cosmos DB is how we configure how data is written to one instance of Cosmos DB and replicated to the other instances. Another advantage of this is that it also greatly increases your availability since you're now running the application in multiple regions. If one region were to go offline, your application will still remain available. So now let's talk a little bit about the consistency levels. Typically, your distributed application will have two consistency levels. Strong. In a strong consistency level, when an operation is completed, it will be available on all nodes right away. Users will never see an uncommitted change or a partial change. They will always be in order. This would be similar to how traditional databases would work. And we can see here in the example, as we write the data ABC, we can read the data ABC essentially in real time. On the opposite end of the spectrum, we have eventual. When a write happens in one instance, it will eventually be in sync with the other instances as capacity becomes available. There's no guarantee the data will be available in the order in which it was written. A good example of this is DNS. When we make a change, we know it will generally be available within a few hours, but have no expectations it will happen right away and be the same for everyone until after a period of time. Another example of this may be for a point-of-sale system. Once a user completes a transaction, typically there won't be any more writes. Your local Cosmos DB instance will complete that order and trust that it will eventually update on the other instances. So we can see here in the example, again, we're writing data ABC, but we can see the read, there might be a big delay and the order might come in CBA or some other variety. Somewhat of a middle ground with this is constant prefix. We still have the same issue when we read the data. There's no guarantee as far as the time that it will be available, but it will always be in order. So if you write an ABC, the order which it can be viewed will always be in ABC. Cosmos DB also provides two more options here to kind of find a middle ground. The first one is bounded staleness. And this gives us the ability to define a limit for the amount of time that a staleness is allowed. The limit can be the max number of versions that you're behind or a time interval. Reads will always be in the same order that is written. Essentially, if that time limit is reached or the number of versions you are behind has exceeded that threshold, it will temporarily use the strong consistency level to where it will go through and ensure that all of the writes are available on all of the instances. Essentially, you're defining a max acceptable amount of lag when using bounded staleness. Session is another consistently available, and it is the default within Cosmos DB. Essentially, connections using the same session will appear to have a strong consistency level. And by session, we mean that the application will pass a session token as part of its request. Cosmos DB will understand that token and ensure that all requests with that same token will be able to see all transactions in real time, regardless of the region. If the request uses a different token, then Cosmos DB will then default to using constant prefix. To put this in another perspective, let's take a look at a table comparing the options and also bring up how it works depending on the deployment type. And you can see here for the deployment types, we've got same region, single master, same region, multi-master, and then the same to where we've got multiple regions, single master, and multiple regions, multiple master. Strong, again, is going to have every transaction available in real time. Eventual, on the other hand, will eventually sync up, but there's no guarantees on when, or things may be out of order. Bounded staleness, again, within the same region, it has the same consistency level of strong. If we move to multi-region or multi-master, it will behave like consistent prefix within the staleness window. Once we go outside of that staleness window, again, either we've passed a certain time threshold or we are a certain number of versions behind, it will convert to strong essentially and go through and make sure all of those writes are available across the board. For session, on the other hand, again, all sessions that use the same session token will have a strong consistency level. For requests that use a different session token, then we'll have a consistent prefix level. The exception here being if it's multi-region or multi-master or it becomes eventual. And finally, consistent prefix. There's no guarantee on when the data will sync up, but it will sync up in order, and again, the exception here is multi-region multi-master, where it becomes eventual. When choosing the consistency level, you naturally want to focus on leaning towards strong, but be aware there's a performance impact for this depending on how your application is deployed and used. Be mindful that if it's predominantly reads versus writes, this may not be as much of a concern. However, the higher the ratio of writes to reads, the more important it becomes to review this. Session is the default and ensures that the application writing will see the consistent data for the entire session. This works for many real-world applications. If your application requires strong consistency, regardless of the session, then consider using bounded staleness. This provides a strong consistency level outside of the staleness window, but can give you the performance benefits of consistent prefix within the staleness window. If your application can get by with eventual consistency, it's recommended you use consistent prefix. The main reason is to ensure that the data is available in the same order that it was written. For the highest level of availability and lowest latency, select eventual. There are no real guarantees with this, but it helps ensure the fastest user experience. Again, think of DNS. It's a relatively low write but high read service that will work in this scenario. With all that said, there is a metric called probabilistically bounded staleness. This will help show you the probability that your clients are getting strong and consistent reads. This metric can be used to help ensure you're choosing the appropriate consistency level for your application. Since Cassandra and Mongo use different consistency levels, that each one has their own approach for maintaining consistency levels. Cassandra, the write level consistency is the same as what is configured for your Cosmo DB account. However, the read level is set by the Cassandra client driver. Since MongoDB doesn't offer precisely defined consistency levels, it considers the write replica as the primary and the others as read replicas. With this in mind, when you define which region is your primary region in Azure, this will be considered your write replica. All other instances will be considered read replicas. Azure will map the read consistency level to what is configured dynamically by the MongoDB client for the read request. Let's see how we can configure the consistency level for our Cosmos DB. Here we are back at our database account. If we scroll down on the left, you can see we've got a couple options again that we're looking at. We just got done talking about consistency, so let's go through and take a look at this. If you remember right from when we deployed our database account, we chose bounded staleness. We also set the maximum lag time per 5 minutes, as well as the maximum amount of lag operations to 100,000. If we wanted to go in here and change into that, we could easily do that just by updating the value. We'll change just to 10. Click off, and then we have our option to save up top now. If we go through and look at the other consistency options, we've got eventual, consistent prefix, session, as well as strong. You can see Microsoft has used the music notes in the bottom right to help explain how the consistency level will work. You can see the top line is writes, and the ones below that are reads in various regions. If we look at eventual, you can see we have data coming in. It doesn't look like it's in order, but we are running with the assumption that everything will come in sync eventually. Again, think about DNS when you think of eventual. Let's discard our changes and go take a look at how we can determine where our data is located. So if we go over here to replicate data globally, we can see right now our write region is US2, our read region is East US2. Additionally, if we look on the map, we can see we've got the light blue check mark over on the west coast, and we've got a darker blue check mark on the east coast. If we wanted to add a new region, say for example we wanted to put something in North Europe, we could click that box and we can see that not only does it also get a dark blue checkbox, but it also shows up under read regions. Same if we wanted to go down to Australia and Southeast, we could set that up as well. One thing that you might notice as well is we only are allowing writing right now to the West US2 region. If we wanted to change that, we could go up here to enable multi-regions writes and select enable, and then you can see that every region still has reads available, but now if we scroll to the right, we can also see that writes are also enabled. Let's go ahead and discard these changes for the moment. Let's go up to failover. If we click on automatic failover, you can see currently it is turned off. If we wanted to enable it, we can hit OK, we hit save, and now it's going to essentially enable automatic failover. Now we can see automatic failover has now been enabled. If we go back up and select it, we can see it's turned on. If we go back, you can see we still have the option for manual failover. We can select the region that we want to become the right region. Obviously we only have one here, but if we added more to it, we could go ahead and select those from the list. So that covers How we can configure our consistency level is how we also would enable multi-region write or expand our Cosmos DB to additional regions. Let's go back and take a closer look at some of the other options within Cosmos DB.